Hello, and welcome to today's webcast, Water System Efficiency and Reliability, brought to you by Water World Magazine and sponsored by Mueller Water Products. My name is Alana Maya. I am Chief Editor for Water World, and I will be your moderator today. And I have a few housekeeping items before we begin. The audio, video, and any slides for today's presentation will be automatically pushed to your screen. And if you're running pop-up blocking software, we recommend that you disable it to view this webcast for better performance. We would also ask that you close down any other programs that you may be running in the background. For technical difficulties, you can submit your issue through the Ask a Question box, and a member of our webcast support team will reach out to you to correct the problem. And the Ask a Question box is also how you can submit questions for our presenter, and we will discuss those questions during the Q&A portion of the program after George's presentation. A certificate of attendance will be issued automatically via the email that you use to register for this webcast within 24 hours. And for your convenience, the presentation will be available on demand within 24 hours of this live event. And a reminder email message will be sent to all registrants with a link to the archive. It will also be accessible for 6 months at waterworld.com. So if you want to go back and view it later, you are more than welcome to do that. One final request before we begin. Your feedback is very important to us, and we hope that you will take just a few moments at the end of today's presentation to complete a brief satisfaction survey at the end of the broadcast. And now on with our program. Quality products enable utilities and municipalities to manage water efficiently for communities. This presentation will cover the inner workings of a 350 PSI fire hydrant and gate valve system, which allows for long-term reliability of water systems. George Lacefield is Senior Training Manager for Mueller Water Products. George served over 23 years in the U.S. Navy as a boiler technician and gas turbine technician, as well as a basic training instructor. And following his naval service, George worked as a field service engineer, providing consulting and troubleshooting on various systems at numerous power plants throughout the country. He began his career with Mueller in 2010 and became the Senior Training Manager in 2018. He's conducted over 800 training courses for utility workers, contractors, distributors, and employees, and we are happy to welcome him to join us today. Thank you so much, George. I'll turn it over to you.
Cool. Awesome. Thank you. Hey, good morning, everyone. If you're watching it live, and if not, well, good day, whatever it might be. Like Alana said, I'm George Lacefield, Senior Training Manager for Mueller, and I've been asked to today we're going to go over mostly fire hydrant maintenance and proper and safe operation of fire hydrants. And this one today is going to be the Mueller 350 Super Centurion. So that's what we're going to get after. We also, like she said, we have offer a 350 max pressure rating hydrant and valve combination, gate valve combination. So these are going to be made. Hopefully you can see behind me there. I'll get out of the way pretty much, but it's a little different than normal. I think probably most everyone's used to just sharing a slide. I just thought it would be better today, this type of training, to actually have a cutaway fire hydrant, slides behind me, and then I have a shoe as well. So I plan to, do some maintenance, take the hydrant apart as well, take the bonnet off, take the shoe out, show you how the main valve comes out and gets replaced and those types of things. So it's a little different, but hopefully it works. Hopefully it works for you. We make our these fire hydrants right now are being made in Albertville, Alabama, which is the fire hydrant capital of the world, is what we call it down there. We've been manufacturing fire hydrants since 1933. Those were first started in Chattanooga, Tennessee, and then in 1975 we opened up the Albertville plant, and since then that plant has produced over 4 million fire hydrants. Over 4 million just out of that plant. Pretty amazing. This is what the plant looks like. I took this picture a few years ago, and I just felt like it was important to show truly this gentleman over here, because that man stands there 8 hours a day, and those guys really work hard, and he pours 2,700 degree ductile iron daily. So it's just a really cool picture. And if you ever get a chance, they love to have guests come in, and they love to give you tours of the plants. And now the COVID's kind of subsiding a little bit. Those are open again. So if you get a chance, and get a hold of one of our territory managers in your area, and hopefully you get to go and check it out. It's a lot of fun. This is As far as the AWWA concerned, the fire hydrant itself is known as the upper barrel. Below that, you'll find the lower barrel, and at the bottom, you'll have where the pipe connects into the valve. That'll be the chute. That's the names. But a lot of people don't realize that there are many upper barrel configurations. So I'm going to call this the steamer, and then we're going to call these the hose connections here. But as you can see back here, we have single hose or steamer connection. We have 2 steamer connections. We can do 4 hose. There are many different configurations. 2 steamer connections, 2 hose connections. We do also offer monitor hydrants as well, which I'll explain more later. Also flush hydrants. What a flush hydrant is it doesn't mean that it's used for flushing water. It actually means that it's flush with the ground. So if you would come up to this hydrant would have a metal plate over it. You would lift it up, and your hydrant would be there. You would find those in very high traffic areas where you would want hydrants, but not sticking out of the ground, such as, let's say, an airport. Somewhere in that airport, you're definitely going to want fire hydrants out there, but you certainly don't want them, out of the ground. That'd be a little dangerous. Maybe a racetrack as well, right? Cars going around a racetrack. So there are a lot of different configurations out there. One recent change in 2014, actually, we started adding this QR tag. This QR tag, because what we found was a lot of the workers, a lot of maintenance operators and stuff, it was very difficult for them to identify the actual hydrant they were working on, because over the years, technology's changed and things change, and improvements are made and hydrants are changed. So what we started doing in 14 was this QR code. So it's right on the side of the hydrant. Anyone can take a phone, a smartphone, they can scan this, and it will tell them exactly everything about that fire hydrant itself, right? Such as year it was made, this is an A421. It'll tell you we've got 1 inch or 1 4.5 inch steamer connection, 2 2.5 inch hose connections. It'll tell you the bury depth. It'll tell you the hose or the shoe connection at the bottom, this being a 6 inch MJ shoe. It'll give you the paint code. Another great thing that you find there is it'll actually take you to our website. And on our website, you're going to find a troubleshooting manual. So if something is just not acting right with a fire hydrant, you can scan that code and you go right there and find it in the troubleshooting manual, and boom, hopefully walk right through the steps to fix it. So it's very, very nice. We've been doing that since 14. Now, hydrants are very well built, whether it be ours or other hydrants, they're very well built. They're iron, and they're made to last, right? They're steel, they're brass, they're stainless steel. The coatings on these hydrants today are just amazing compared to back in the old days. They're going to last, they're going to shine, and they're going to look good for a long, long time. But these hydrants are not bulletproof, right? So they can be operator error. You can really mess these hydrants up if you don't know what you're doing. So hopefully we're going to go through that today to help you out and just show you the inner workings, how that works. And maybe you can see that behind me there. Hopefully you can see the slide deck. And this is just proof that they're not bulletproof, right? So I guess some areas of the country don't have a lot to do. They just use the fire hydrants as target practice. That's actually, it's an actual Mueller fire hydrant, and it's got holes in it. And we thought we'd open up the hydrant and let the water flow out and make for a great picture. So we also recommend when you're out there and you're working on the hydrant that you actually use the proper tools. We see a lot of things out there. There's a lot of brass, the hold down nut, the operating nut, the hose connections, all brass. We see a lot of pipe wrenches and things of that nature, and we tell guys, hey, we really truly recommend using the proper tools that are made just for the hydrant, and those being fire hydrant tools, right? And there's very, very many different variations of those. Certainly don't want to use a pipe wrench on any part of that hydrant. This is just a picture. You see things all the time out there. I came across a guy who was actually flushing hydrants with a brick. And I'd never seen that, so I took a picture of it. And we helped him out a little bit. Now he's got a regular fire hydrant thread, so he's a pretty happy guy. So let's go ahead and talk about the hydrant itself. And when we're talking about buried depth and getting the hydrant in the ground, the buried depth for a fire hydrant is going to be, there's going to be a line in your lower barrel. And your lower barrel just below your upper barrel, your fire hydrant bolts down here where it bolts into the lower barrel, there's a line there, and it actually says bury. And if the hydrant is buried properly to that bury line, then the hydrant, which if struck by an automobile or something, it would truly break and dissipate the energy, and it's a safety concern. So what we see all the time hydrants buried, they'll get landscaped in, and when those things happen, they need to be raised up, like putting an extension or riser, some people call it. But the minimum bury depth on a fire hydrant from the middle of the pumper to that ground is 18 inches. 18 inches, and again, we see all kinds of things. That one just only has a bonnet sticking out. You see these all the time. But these need to come back out of the ground. You need to raise them up. And so proper height, 18 inches minimum from the middle of the pumper to the ground line. Your firemen will really appreciate that when they're putting the wrenches on there and spinning these caps off and putting their hoses on. They'll actually have some room to get that done much quicker. So 18 inches, middle of the pumper to the ground. Different parts of the hydrant. The fire hydrant itself, at the top, you're going to have the bonnet. This is going to be your bonnet up here. This one has flutes in it, trying to make it look like a fireman's helmet. That's what we look for there. It's going to have an oil filler plug on the side where it's for your lubrication. You're going to have your hold down nut, which holds down your operating nut when operating the fire hydrant. And I'll just, what everyone knows what they don't know, but we'll just talk about basic operation. When operating this fire hydrant, right, you're going to take your hydrant wrench, you're going to put it on the operating nut, and you're going to turn the operating nut to open and close. And right on top of your bonnet, it will tell you which way to open the fire hydrant, because there are many open right hydrants as well as, of course, open left hydrants out there, and some areas, you might get mixed up. So you put it up there, it tells you which way to do that, right? But what a lot of people don't realize is when you're operating the operating nut, the stem inside is not turning. What's happening here is you're turning the operating nut. The threads in the operating nut push the stem straight down, right? Which then opens the hydrant, because the actual main valve of the fire hydrant is all the way down into the shoe. And I'll hold that over and let you guys see that. You see how this is your fire hydrant shoe. This is your stem. This is where your pipe would go in with your valve right here. And the main valve will open. And I'll take that out so you can see what I'm talking about. Right? Here's your main valve. This is where you get your seal. So the operating nut pushes the stem down, which pushes the main valve open, and water flows up and into your hydrant. When you close the hydrant, right, when you turn it, this hydrant actually operates 17.5 full turns. You're going to then be pulling the main valve up, right, with your operating nut, and it'll actually be closing the hydrant, and the seal will become between the main valve, which is made out of rubber, and the brass seat. Right? So that's how it goes. This hydrant actually operates 17.5 full turns. When it operates those 17.5 full turns, on the bottom of that, there's a iron cap nut, which holds everything together underneath, right? And when that iron cap nut at 17.5 turns hits that iron shoe, then that hydrant is fully open, right? We definitely recommend flushing hydrants at least twice a year. And when you're doing these, right, these flushes, we want that hydrant open fully every time. There's a couple of reasons for that. One reason is I've seen many times out there. The hydrant team or the flush team will go out and they're concerned about losing a lot of water, and they're concerned about where the water's going and washing out somebody's garden or whatever. But what you're doing there is they're only opening the hydrant 5 or 6 turns. And what you're doing is you're pulling that main valve off that seat just far enough for debris, rocks, stones, a lot of things get caught up in there. And then you close that hydrant on those rocks and stones in between that rubber and that brass, and now we're going to have a leaking fire hydrant. Meaning, from then on, the fire hydrant will continue to fill with water even when closed, and that main valve is going to have to be replaced or repaired. So we always recommend flushing the hydrant twice a year, get everything out of there, and opening it fully 17.5 turns. You want to get that wide open, so anything that happened to be caught up in there can get out and not cause any problems later on. You certainly don't want to over-open the hydrant either. When I told you when you open it all the way, that iron cap nut hits the bottom of that iron shoe, right? That's it. That hydrant is fully open, and you're truly not going to get any more water. Also seen some people think that they could just continue to operate the hydrant. So they'll get a 9-foot piece of pipe and put it on a wrench, and sure, they'll get the leverage and they'll get it moving, right? But really what you're going to do there is just, as you see in this guy, he brought this in, and someone has over-opened that hydrant, bent the stem, and that stem's going to have to be replaced now. So again, they're not bulletproof. Just operate them the full 17.5 turns, let it flush, close the full 17.5 turns, and then we recommend once it's closed, kick it back a quarter turn. We want you to kick it back a quarter turn. That way the hydrant, the main valve, is not pulled up into the seat and deforming that main valve. Again, that main valve made out of rubber, right? So that's what we want to do with that. All right, let's go ahead and get into this. Our scenario today is we're going to change out that main valve seat, right? It's like it's leaking. We got a seat leaking, so we're going to get on this fire hydrant and we're going to get the bonnet off, and we're going to get our big wrenches. I don't have big wrenches in here today. We're actually going to do that, but I'm going to show you what it looks like. So first thing we're going to do when working on a fire hydrant to change out the main valve or doing an inspection down there on the main valve is we need to cut the water off. So just shut the water off to the fire hydrant, right? Close the guard valve, the auxiliary valve, the gate valve, whatever it's known as in your area. And then I always recommend cracking open a cap and making sure there's no pressure in there before you start. It's just dangerous. There could be a lot of pressure on it. So now we're going to need to get the bonnet off. To get the bonnet off, I'm going to take the nuts and bolts loose on the bonnet, which we've already done. The hold down nut will need to come off next, right? Because the hold down nut is holding down the operating nut. Now the hold down nut is actually reverse thread. So all you got to do is look, and it says open the fire hydrant right here. It'll say open it that way. So to remove the hold down nut, you just go the opposite way, right? And mine doesn't have 40 coats of paint on it, so it comes off pretty easy right there, right? They don't come off that easy in the field, but mine does. On your hold down nut on the outside, you're going to have an O-ring seal. You're going to have an O-ring seal on the inside. And then on top of that, we have a little rubber gasket here. We call that the weather seal. And the weather seal will seal out, of course, the elements in the weather. Those things are very important. Make sure they're good to go. Now, if I'm operating that hydrant, that full 17.5 turns like we talked about, and there's no hold down nut holding the operating nut down, the hydrant is not opening, but what's happening is the operating nut is coming up. So here comes your operating nut. On your operating nut, you're going to have a thrust collar right on there, which is built into the operating nut. And on top of that thrust collar is a little plastic washer, right? And it makes sense to call it the thrust washer, but we don't. We don't call it the thrust washer because that's not what it's there for. It's actually there for as an anti-friction washer. So if you didn't have that there, and you had your hold down nut sitting on the thrust collar of your operating nut, then you would have metal on metal, and that. So what we do is we put that anti-friction washer on top, and we recommend that it goes back once you work on your hydrant. Because many times I've been out working on hydrants and it gets lost, so it's not there. It's wherever, I don't know, who knows where it's at. Now let's talk about our operating nut. Let's talk about what's going on in here when we're flushing our hydrant. The only preventive maintenance recommended for this type of hydrant here, because it's an oil lubricated hydrant, is to fully operate the hydrant, open and fully close the hydrant. When you do that, what you're doing is you're running the stem down, stem threads here, right, through the oil reservoir inside here. So it's going through the oil reservoir. And as the stem goes down, right, it will open up this hole inside the operating nut as long as you open it the full 17.5 turns. And the oil will then will fill into this cavity inside of your operating nut. So then when the stem is closed, when the hydrant is closed, the stem goes back up, closes off the little hole in the bottom, and then pushes this oil that got trapped in that cavity out of the two top holes around your anti-friction washer. So simply by operating the hydrant all the way closing the hydrant all the way. That is the only preventive maintenance we recommend on these hydrants, and would like to have it twice a year, if possible. All right, a lot of guys are out there. I know there's a lot of work going on, and at least once a year for sure. You definitely want to do that, but we'd love it to happen twice a year. Now the oil and the oil reservoir is a special type of oil, right? There's we recommend you're not going to put 30 weight oil, no petroleum oils, no none of that kind of stuff, because you have O-rings in there for one thing, and plus, if that oil was to get into the system, we don't want that. So we only recommend hydrant lubrication oil, and that is a food grade oil as well. So it'll be safe for the water system. Now, when filling up the fire hydrant with oil, right, the reservoir holds 9 ounces. The bottle will send you, will have 10.5 ounces. And we do that for a couple of reasons. One reason mostly is so when you take out the oil filler plug and you squirt it in there, you don't have to measure. As the oil overflows and comes out, that's 9 ounces of oil. Put the oil filler plug back in, and you're done, right? You just did it. So that's pretty much why you get the extra oil. Now, at this point, if I need to get the bonnet off so that I can then hopefully turn the stem and get the main valve loose so I can pull the main valve out. But as I said, the oil reservoir in here, there are 2 O-rings on the bonnet right here that are keeping the oil in and keeping the water out of the oil, right? And there's a copper sleeve in here. And those 2 O-rings are seated on that copper sleeve. Now, once you pull the hydrant bonnet and those 2 O-rings leave that copper sleeve, then all your oil is going to dump out. So we recommend this little tool right here. We call it a brass safety sleeve. And what a brass safety sleeve is going to do for you, right? Let me get caught up here. There you go. Brass safety sleeve. It's going to go down over the top of your stem threads, and you have one person hold down while the other people lift up. And those O-rings in that bonnet will transition from the copper sleeve to the brass sleeve, right? And it will retain your oil in the bonnet, so you don't have to change the oil out. There's no every 3,000 mile change out on the oil, right? It's food grade oil. It's good, right? You like that one? Yeah. And also, it will protect your O-rings from the stem threads themselves. So again, one person would just hold down, the others would just lift up, right? The O-rings would transition, right? And you would be good to go. Oil stays in, we're good to go, protected my O-rings. I also recommend taking the bonnet O-ring, put it on top of the bonnet, because we had numerous times we forgot to put that thing back on there. It's possible, and it happens. So that brass safety sleeve is a nice little tool to help you out. On the upper barrel, there's a lot of information on the back of it. One thing, this hydrant, 350 hydrant, is an AWWA, it's AWWA standards, American Water Works Association. It also is UL and FM. So it's UL listed and FM approved, UL being Underwriters Laboratory and FM being Factory Mutual. So you'll see that information on the back. But one big thing on there, this hydrant that I got today right here is a 4 1/2. The hydrant listed here is a 5 1/4. That's your 2 most common sizes. And what a lot of people believe that indicates is the barrel size of the hydrant. But truly, those numbers, 4 1/2, 5 1/4, that's indicating the actual main valve opening size. So all the way down in the shoe, the rubber main valve itself, right, that's telling you what the opening size of that main valve opening is, either 5 1/4, 4 1/2. And it actually says that right on the main valve as well. So main valve, we'll go ahead and we'll get working on that in a minute. But first we got to get this thing turning. And I'm going to tell you, if the hydrant's been in the ground a long time, it is very difficult a lot of times to break that loose because of tuberculation, corrosion, and those threads all the way down, depending on your buried depth and everything, soil, just a lot of things that affect that, right? So it's a lot of times very, very, very difficult to do. So we got a couple wrenches for that. One thing I do recommend as well is if you have people out there watching you work on your hydrants, which you do a lot, I do recommend safety chains on a fire hydrant because the caps can get pressure behind them and blow those off. And that's just a picture I took of some guys who were out in California, not only watching us work on a hydrant, they were telling us how to work on a hydrant. Let me tell you, it was pretty amazing. And a lot of times today, they're filming you as well. You see that a lot. So this is your wrenches. We make small wrenches that go down, and there's a cross pin right here, and you can catch that cross pin, and hopefully a small wrench like the A35900C removal wrench will get it done for you. But most of the time, that's not the case. You're going to have to use one of these long, tall wrenches right here. Right, I was just waving at the conference lady. So she's through the window there. Sorry about that. But long wrench goes all the way to the bottom and comes all the way down here. Grabs your wrench flats on your main valve. You can put a lot of guys on it, four guys, just like these guys did here. And hopefully we'll get all that power not generated through the stem, but generated right here where we need it, and we can break that main valve loose. There are numerous wrenches out there that are specialty wrenches for that. One I recommend is this. It's called a mill seat removal wrench. It's a big, heavy, hefty, squared wrench. It's got one arm off the side, and a lot of times we recommend using that truck power, right? You can use that truck power, or if you got a backhoe bucket out there, hit with the backhoe bucket, and we'll break that thing loose for you. So let's say we're able to get it out, and we broke it loose. What you're going to do then is you're going to pull the stem out from the top, right? We'll take the main valve assembly here, the stem, and normally just throw it on the tailgate there. And what we're doing here is we're trying to get to that main valve that's been damaged through rocks or stones or whatever, and we need to get that thing changed out if possible. So I recommend, first thing you're going to do is you have a stainless steel lock washer here, and in the factory that's bent one way and bent the other way. And that's there to act as a lock washer so the iron cap nut can't work itself off, right? So you have to take a flat tip screwdriver, whatever, and straighten that out. Then here comes off the iron cap nut will be first to come off. You got a gasket in there that protects these stem threads from the waterway, so make sure you get that. Then it comes off your stainless steel lock washer as well, right? Now we're able to get to the lower valve plate and then to the main valve. Now, if the hydrant, for a Mueller hydrant, Centurion hydrant, if it was 97 or newer, it's going to have a lower valve plate with a lip. If it's older than that, it's going to be a flat. Thank you. Your lower valve plate will be flat, and your main valve will be flat on one side because that was a one-time use, right? But in 97, we changed that and we made it into a reversible main valve. So if one side is damaged and the other side is still good, right, you can flip that thing over. You got a repair part right in the original part. Now, as I said, these are rubber. They're very, very hard, right? They're harder than a hockey puck. They're 95 rubbers of hardness there, but they're still not harder than rock. Well, one recent change we did when we went from a 350 hydrant, we were able to get it up to, from 250, and we were able to get that pressure rating up to 350, was we changed the makeup of the main valve. And what we did was we added, an iron core. So your main valve has got an iron core, very thick, heavy iron core now. It's still fully encapsulated in rubber. There's no iron exposed to the waterway, right? That's a huge bonus for you nowadays. Matter of fact, it works so well with the 350, we just started making it standard in all of our hydrants. So all of our hydrants now are going to have that. So that's very nice. So got 2 O-rings down here, right? And if you get the repair kit, you're going to have those O-rings there. The upper O-ring is just slightly bigger than the lower O-ring. So what we do is we recommend that you make sure you know which is which. And what we do, when you pull them out of the package, it's very difficult to tell. So we actually put a little white dot. It's got a little white dot on it. The upper O-ring, the larger O-ring with a white dot goes on top. So we got it changed out there. We'll go ahead and put it back together. There's my lower valve plate. We'll put the stainless steel lock washer with my rubber gasket. And then again, We tighten up the iron cap nut. And again, we want to recreate that stainless steel lock portion. So I recommend taking a hammer, hit one side one way, and the other side the other way, and that'll create that lock portion. And we got it all changed out now. Now we're going to take it back over to the hydrant. Good to go. We're going to lower it nice and slow down in there. We're going to want to roll these O-rings out. As you can see here on the main valve, it's a brass main valve, right? So the threads are brass. And again, we talked about the shoe was iron. So we don't want to thread brass into iron, and we don't. We actually thread brass into brass. So inside here is what we call a floating drain ring. Floating drain ring, the floating drain ring moves. And when you drop that down in there nice and slow, depending on how deep it is, it might be difficult to line the threads up. And it'd be very easy to cross thread. So what we recommend, because it's a floating drain ring and it moves, we want you to back it up, right? Turn it backwards. And you're gonna hear that noise. If you turn it backwards at least 2 full turns, right, and you hear that, then the threads, the floating drain ring, just lined itself up for you, and that's the purpose of it. So put her back in, tighten her back down, put her all back together, and you are good to go. Right? So we got a main valve change there. Oh, there it is. Sometimes we get a little lost. There we go. So now let's talk about our brake flange here and our brake coupling here. Very, very important, especially after, if you put on an extension, that you ensure that the brake flange goes on the bottom of the hydrant and is out of the soil. It's not buried, right? Because it needs to be up there so it can break. So when a hydrant is hit, struck by a car, it breaks here. It breaks, the stem's going to have to break, right? Right? The energy goes this way and protects the people in the car. And then it's very easy to fix it, right? All you would have to do is replace the brake flange and replace the brake coupling. I'll show you, we made a change a few years ago in our brake coupling as well. You'll run into this one. They're both stainless steel, but you'll run into the old tearaway style out there. And those, they work just fine and everything, but it was just difficult to get the pins in and out after they were hit. So we went to a new 3-piece brake right in the middle. So this breaks off much cleaner. It's much easier doesn't put a lot of stress on your pins. We also made it longer. We made it fit tighter, and we did that because we tried to take the play out between the 2 stems, right? The upper and lower stem, and we even made the holes a little bigger so you get the pins in and out a little bit easier. So there you go. Now that only fits one way because there is a lip in the middle, right? Well, there's a lip on the inside. That way, when you put it on, it doesn't go all the way down to the bottom, right? So, but that lip is not right in the middle because the brake is right in the middle. So there is a certain way it'll go, and the holes won't line up, or they will line up. And if you look right on the side, it says this end up with an arrow. So we try to help you out with that. But I've seen it the other way before, right? And that'll really, you won't get that full 17.5 turns after that, I guarantee. All right, so an extension kit. We make extension kits. That's for when the hydrant's buried, as we talked about earlier. You got to get that hydrant back up out of the ground, so it's supported, exactly where it is. It's supposed to be. Those extension kits run 6-inch increments. So there's 6, 12, 18, all the way up to 4 foot. We make them all the way up to 4 feet, and we recommend only 1 extension per fire hydrant. Right? You don't want to put a lot of extensions in there. If you do, you're going to have a lot of extension stems and couplings, and then everything in there is going to be just doing like this as you're operating the hydrant, water flowing through it, and it's going to wear itself out. So maximum number of extensions, 1. Another change we made recently was to those extension couplings and those brake or safety couplings. And it was not to the actual coupling, but it was to the pins that hold them down there. A lot of people didn't care for the old cotter pin style, so we've recently gone now to a retaining clip. So again, you just still have to use a pair of needles, pliers. You reach in there, but you turn it over and you pull it out. So much, much easier for maintenance. Put it back in, click it back over, you're good to go. Again, here's some pictures we've taken over the years, just showing you the importance of opening the hydrant fully every time. There's a lot of debris in there. You'd be surprised. This has a plastic cup. This one's showing a pipe gasket. This one's very common. You see a lot of rocks, This one had 2x4 and a test ball in it. This one had enough rocks to fill a 5-gallon bucket. Just amazing the amount of rocks came out of that. So make sure you open it fully each and every time you operate it. Every hydrant is going to be pressure tested in-house. It's going to be full of oil before you get it. It's going to be painted to your whatever your specs are, and it's also tested to 2 times over before it ever leaks. So it's already been tested before you get it. This is a monitor style hydrant. I showed you this earlier. I was going to talk about this. And this monitor is for areas where you're going to add one of these monitor devices to this part of the hydrant. Some people call it a water cannon. Some people call it a deluge device. What that's going to do is you're going to use that at power plants. You're going to put that lumber yards, refineries, anywhere where a fire could get out of control very, very quickly, very, very intense fire, and the firefighters might not be able to get in there close enough. So you have these facing where you want them to go. Sometimes they're operated electronically. You can push a button in the control room and open the hydrant and fight the fire for you. Very cool. So those are out there as well. The new paint system on this hydrant is a 2-part polyurethane paint. Again, in 2014, we went to this new paint system. Instead of the old oil-based paint, we're priming them first with an Americoat 370 primer. We hit it with a 2-part polyurethane Sherwin-Williams hardening paint. These things are great. It really is really nice what they've done, the changes they made. They wash everything before they hit it with anything. Then they hit it with infrared dryer. Your hydrant's going to look great. Your red hydrants aren't going to be pink in 2 years. They're going to be out there, going to look good. So that's good. This is an optional shoe that we offer out there, and that's a lot of people call that a backflow preventer. It's a check valve. It's a check valve in the shoe. It will not allow anything to go the other way, right? So it's called an HS250, which is a high security check valve shoe. In areas where they're worried about someone possibly poisoning the water system through a hydrant, they're going to want to put those in there and provide protection. There are also different ways to protect the hydrant as far as anyone doing anything, stealing the caps, stealing water. There are numerous ways to do that. We offer a stainless steel, what we call a defender. As far as I know, it's the only one out there that protects all of the caps as well as the operating nut in one device. This one right here is also very popular. That's called a Knoxville device, what we call it. It goes in, you'll take the old hold down nut out, the brass one, you put this iron one in, and then the only way to operate the hydrant, right, would be to have the proper wrench that goes with it. So you would have those, the fire department would have those, and we keep, you'll see that in areas where certain hydrants somehow they get used a lot. They're, filling up wherever they're filling pools or flooding, farms or whatever they're doing, ponds, still water. So there are lots of things out there you can use to stop that, combat that. The 350 hydrant, there were a lot of improvements made when we went to the 350. The main one I showed you was the main valve with the iron in it. Also, it's got a high grade nut and bolt as well. A lot of different things like that. Single groove flange as well on your brake flange. It's going to have if you get a brake flange and you see a groove on one side and a groove on the other side, that's going to be for your Super Centurion 250 and below. This one, the 350, is going to have a stronger flange, and it's going to be a single groove. So you find that single groove flange, that is for a 350 hydrant only. This is a new hydrant we came out with not too long ago. We call it the A403. It has all the same internals as the Super Centurion fire hydrant. The main thing different is what we've done, and I got a little one right here, a little 3D model. Show it to you, right? But what they did was they took the hydrant and pretty much they cut it in half. And then they put this clamp in here, and now you have 2 bolts. And what that does for you is allows you to take the hydrant off over the stem. Oh, I'm doing that on there. My finger is doing that. Let me pitch back up. Am I going the right way?
Other way.
Oh, I'm going the wrong way because I'm looking at it backwards. That's difficult to do, just so you know. But what it does is it allows this to come apart in two pieces, which meets OSHA's rule for a one-man lift. These hydrants are, very, very heavy, and if you take those apart and you take it off in two pieces, very nice. And also what it does, it eliminates the 8 bolts right here on top of the bonnet. So again, you're getting rid of those 8 bolts on the bonnet, just taking the 2 bolts off here, and you can remove it in 2 pieces. That comes in a 350 hydrant only, in a 5 1/4 right now. So that's what we're making it. It's AIS compliant too, if that's important to you. So again, this just shows the inside. It's got a very high strength 3/16 stainless steel nut and bolt as well, standard on this hydrant. Very, very nice. And it comes in 3 different heights as well. If you want the nozzles off the ground a little higher in snow areas where it snows a lot, we make 3 different heights with that. And be careful out there when you're working on a hydrant. It's just funny how that's a picture taken in Chattanooga, Tennessee, and when you're out there, they will absolutely if you leave stuff out there, they'll take it, and which is fine. We didn't really mind because they got rid of the old hydrant for us. So hopefully I didn't go through that too fast. That is hydrant training that hopefully you enjoyed that. Hopefully you got something out of it, make your job a little easier, whatever you're doing out there. And hopefully I explained it well enough where you can understand now how the inner workings of a hydrant. When you open an operating nut, you're really just pushing the stem down, opening the main valve in the shoe, closing the hydrant, pulling the stem up, closing that off. So now it's I'm ready. I guess we're right at 15 minutes prior to any Q&A, any questions. I'm available. Stand by.
Great, thank you so much. So you're right, at this time, we'll move into the question and answer portion of the program. And just a quick reminder, if you're listening live and you still would like to ask a question, you may do so by using the Ask a Question box in your presentation window, and we will get through as many as we can today. And if there are any that we don't get to, we can answer them offline. They will be forwarded to the presenters later. So
absolutely.
Let's see here. So the first question that I see that came in is from somebody that says, this is a great discussion on dry barrel hydrants. Please touch on wet barrel hydrants if you can. And sure. Also when opening a hydrant, is it good practice to stand on the side without a connection in case the caps fail?
Absolutely, I totally agree with that. I failed to mention that when you are doing any type of maintenance on the fire hydrant, absolutely you want to stand behind the hydrant, out of the way of the caps. Again, because this is brass in here, the pressure could get there, and those caps could blow off and certainly injure you very much. Very good point. Absolutely, always stand behind the hydrant. I can touch on wet barrel hydrants. I don't have a wet barrel hydrant here in the conference room right now, but the big difference is this is a dry barrel hydrant, which means these are going to be in the cold climates where you're going to have the water below freeze line there, so all the way down. But in your warmer climates, say Southern California, wet barrels are very, very popular because it's just not going to freeze. What a wet barrel would mean, the water is all the way up into the hydrant all the time. If you've ever seen a movie and you've seen a fire hydrant hit and you see the water fly out, that's because that's in Southern California where they made that movie most of the time, and that is a wet barrel. I call it Hollywood hydrants, what I've always called it Hollywood. Just so you know, a normal hydrant, a dry barrel hydrant hit, like as everything works, this water's not going to come out, right? The main valve, the water pressure is underneath the main valve, keeping it shut. So that's the big difference. And as far as wet barrels go, another difference in the wet barrel, which is very nice, is that each individual hose and pumper or steamer connection will be operated individually. So if I had a hose connection here, the valve would come through and would be operated on here. My pumper would be a little bit different, offset, and it would be operated itself. So it's just very nice for firefighters. If a firefighter comes up to a wet barrel hydrant and takes the cap off and hooks his hose up and opens that, he's got water to that hose. If he wants to then go to another cap and connect another, he can do that. He can take the cap off, connect to it, and open up that nozzle and have water to that one. Now, dry barrel, you're not going to be able to do that. If I take cap off, hook the hose up to it, and open my hydrant, I'm not going to be able to remove my other hoses or hose caps because water's going to be coming out, right? So a lot of times you'll see them before they even open hydrant, they'll put a couple gate valves on these, and they can individually open. Then now you can operate them individually as well. So that's pretty much just a touch on the wet barrel there and the main differences. And I can tell you that maintenance on a wet barrel is very, very simple. If you were to happen to have, like we talked about, changing out your main valve on the dry barrel, sometimes it's very difficult to get that thing out. On a wet barrel, they just turn them right through, and it's very, very simple. So I kind of like the wet barrel, to be honest with you.
I like that Hollywood hydrant reference. That's great.
There you go.
So let's see. I've got a few more questions coming in, which is great. So the next one, let's see here. What are the benefits and disadvantages of the 5 1/4 valve versus the 4 1/2 valve?
Well, the benefit is you're going to have a larger opening, so you have a much higher volume of water. So anywhere that you're going to need, a lot of water to fill a truck, they're going to put the larger hydrants in. That's the main benefit. Just more water. Openings larger, you're going to have more water for the fire breaks. The disadvantage, it's heavier. It's just a heavier hydrant, and really there's not a lot of difference between a 4 1/2 and a 5 1/4, other than that main valve size. And the barrel size will change. The barrel on a 5 1/4 is bigger, but that's not what's indicated by that number on the back. But sure, there's not much difference at all, other than just the size and the volume of water.
Okay. This next person says, if I'm using a Dixon PSI data logger on the hydrant in my city, I keep hearing that the hydrants are not made to put PSI dated loggers on them. Is this true?
Can you say that again?
If I'm using a Dixon PSI data logger on the hydrant in my city, I keep hearing that those hydrants are not made to put PSI data loggers on them. Is that true?
Wow. I don't know the answer to that. I've not heard that. So honestly, I can't give you an intelligent answer on that. But I tell you, I will. I am going to look it up myself. I have not heard that yet. So that's the first I heard that. So I'll try my best to find that answer for that as well. But I just don't feel comfortable giving an answer to that right now.
Yeah, and I'm getting a note here that we have the person who asked the question, and we have the email for that person. So we'll definitely reach out.
Awesome.
Yeah, perfect. All right. So the next one I have is: does one have to record and have documentation on when hydrants were flushed and oiled?
Do you have to have? No. I mean, every city takes care of their own, and a lot of cities are they used to use cards, and they would have almost index cards. We had those. We would give those out at Mueller to any maintenance on a hydrant. We definitely recommend you record the maintenance on a hydrant. Absolutely, hydrants, valves. It's nice to know what's in the ground, what you got. But every city, they control how they want to do that. So nowhere does it say you have to that I know of do. But I definitely recommend, especially today with computers and everything, you can really do that very, very easy. And it's nice to be able to go back and because as people change over, to know what you got, what's in the ground. Certainly.
Perfect. All right. And then how do you envision the fire hydrant changing over the next 20, 50, or 100 years?
That's a great question. I love it.
No pressure, right?
No, I love it. It's already changing. The hydrant is already changing. One thing I can tell you right here, right? Maybe you noticed it, maybe you didn't, but this pumper cap is actually a little larger than normal. And you say, well, what is that all about? Well, that pumper cap is what we call an Ecologics DX. And that is a leak detection device right in your hydrant. All you do is change out your pumper caps to the Ecologics DX. It has all the inner workings inside of it. The caps talk to each other, and now you have permanent leak detection right in your system. So that's a huge, huge thing, right? Also, there are a lot of smart hydrants out there as well now, and doing just that, giving you your leak detection, also your pressure. You'll change out the lower stem, and the hydrant, you'll be able to know your pressures in your system as well through these smart hydrants. So that's a huge, and these things are, you can add these brand new, or you can do retro kits on these as well for your existing hydrants. So that's absolutely where I see it going. Your hydrant's going to be not just for firefighting anymore. They're certainly going to be out there to help you and to do things the correct way in your system. Beautiful, great question.
Awesome. Well, we're getting to the end of the time that we have today. So at this time, I do want to thank you so much, George, for taking the time to address our audience. And on behalf of Waterworld and Endeavor Business Media, I'd like to thank our sponsor, Mueller Water Products, for today's presentation, Water System Efficiency and Reliability. As a reminder, this presentation will be archived within 24 hours and can be accessed at waterworld.com for the next 6 months. A reminder email message will be sent to all registrants with a direct link to the archive. And if there were any questions that you asked that did not get answered during this time, they will be answered offline as well. So, expect the presenters to reach out. Please take a moment to share your feedback with us by completing the brief satisfaction survey at the end of this session. A certificate of attendance will automatically be emailed to everyone that was live today within 24 hours of today's event. And with that, we thank you for joining us and look forward to serving you with future webcasts. This concludes today's presentation.